Greetings to one and all. In this session, we are going to study some more concepts related to the unit functions. So to start with, let me introduce you to what we are going to see today. We will see whether default arguments we can pass in C language or not, and what is call by value. Scope and lifetime of a function we have already seen in our previous units of C language, but I'll revise it once again. And what is implicit and explicit return by a function? Is there any difference between functions and procedures? Actually, nowadays we interchangeably use the terms functions and procedures, but there are certain subtle differences between them which are noteworthy, which we'll be discussing, and they're not exactly same, but they're similar. And what are static functions? How can we nest the functions? And what is meant by inline functions? These three exit, abort, assert are predefined functions defined in C libraries, which you can simply call in your program using these function calls, which we will see next session, which we'll see in the next session. So now let me quickly revise what are the advantages of using functions. We can group all the logically related statements into a single block. So what is the benefit of this? It improves user readability and it can help to debug your program. A bug is nothing but an error in your program. And if all the statements which are related are in the same place, you can easily remove the errors or debug your program. Then redundancy means duplicate statements can be avoided. Modularity, your bigger program can be divided into smaller parts. That is, you can distribute the solving of your program into different functions. You can call different functions so that you can find the solution to sub problems. And then these solutions of sub problems you can combine to find the solution of the original bigger problem. And then you can reuse your code once you have written, tested, and debugged it again and again. How can you use your code again and again? By calling the function multiple times. Means what? You can either write function call statements multiple times, or within a looping statement, you can add the function call statement. So the function call will be called again and again. We'll see such programs. Then syntax of function we have seen. Return type should be mentioned first. If nothing the function is returning, then the return type is void. Then you have to specify the name of your function. And then whatever arguments, if you are passing, the list of arguments must be present. This whole first line is your function header. You can have multiple statements within your function. And last statement is usually a return statement if you are returning any value, but it is not compulsory. And make a note that you can return a single value or expression using functions in C++. Means what? You can either return a single variable like return A, or you can say return A into B plus C. You can return any expression like this because the final value of this expression is suppose some integer value, then it is a single value. So you can return a single value like this. But you cannot do a return A comma B or return A comma B comma C. Like this multiple variables or values you cannot return like this by separating them with comma. You cannot also do A into B comma C plus D. Such expressions also you cannot return because here multiple expressions are there which you cannot return using return statement. So what will happen? You can return only like this single variable or a single expression. This is a noteworthy difference of between the functions in Python and between the functions in C++. Remember that C++ allows returning a single value. Python supports multiple value return. Now, also note that if you have any statement after your return, any other statement, then for this case, they will not get executed because once there is return, what will happen? Whenever you call your function from your main, the control will jump to the header, execute the statements. Then when it is returning value, the control will jump back to the function call statement. So these statements after return will get ignored. They will not get executed. So there are ways to handle these cases, which we'll see in our real-time programs. For now, So you can call your function using the same name. Okay, so this name and the name in the header should be same, and you can pass your arguments or values which will get assigned to the list in your function header. And after function call you can have other statements. I've explained the basics of functions in my previous video which I've shared with you, so you can go through it as a part of revision basis. Now we know that in Python you have different types of arguments which you can pass. Okay, so this is the syntax of this is the syntax of functions in Python. You have to use def keyword followed by name of the function, and you can pass your parameters. Parameters also are optional. It depends on your choice of coding. You can have statements and return values. So def keyword is important in Python, and within indentation you must specify the statements. Now the types of arguments that you can pass are required arguments or positional arguments, default arguments, and keyword arguments. So required arguments are nothing but the what you have been seeing in C language up till now. Means what? You can define your function, pass, you can hold in your function header, you can have the argument list ABC, and you can accept XYZ either from the user, or you can initialize. You can accept from the user using input function. In C, what we use scanf function. And you can call your function with the same name by passing the arguments to it. These are your required arguments in Python. You can run such a program. Default arguments in Python means what? It allows you not to pass all the arguments when your program is running. Means, or if you're at compile time, if you want to pass your arguments, means what? Through function call you can pass arguments. Means even if you don't pass all the arguments, but if you're using default arguments, it will not give you an error. For example, def keyword add, and you're passing the default value 5 to C. The default value 5 is getting stored in C parameter. But at your function call, you're passing only 2 values. So X will get assigned to the whatever values of X is, that will get stored or assigned or copied to A, and whatever is the value of Y, that is 7 in this case, and X is 6, Y is equal to 7, will get stored in B, and the default value of C, that is 5, will be used. Now, if you pass another argument at your function call, then what? That argument will get assigned to C, and the default value 5 will get ignored. Whatever value you pass, that will get used for C in your statements of your function. So ABC will be what? Whatever values you have passed, and you can find the sum and print the sum using print function. In C we use printf function to display any message. And you can always pass your default arguments from right to left. You already know this. Now, do you know why this is necessary from right to left? You can think about it for a moment. So let me show you why. See, for example, this is a normal function demo program that I've written in C language. I'm calling mul function, MUL, and I've defined it here with return type void, means it's not returning anything. I'm passing 2 values, 5 and 6. 5 will get stored in A, 6 will get stored in B. But if I pass only 5 over here, and if I run my program, it will give me error because 2 arguments are required, but I'm passing only 1. So what is the solution in Python? You can assign default value to B. So if you assign the value 3 to B, and if you call function call, you pass only 1 value, 5 will get stored in A. So A is equal to 5 and B is equal to 3. 5 3s are 15, you can print. Now suppose I don't use my default argument to the right, at the right. if I don't start using default arguments from the right side of my argument list, but somewhere in the middle or in the beginning, and if I'm passing only one value, then what? 5 will get assigned to A, 3 will be ignored, default value of A will not be considered, whatever value you are passing will get assigned to A. And so B will not have any value. No value is passed to B, it will give you error. Now if I pass 5 comma 6, then 5 will get stored in A and 6 will get stored in B. It's okay. But if I'm using a single value, then B is not getting passed any value, so it will give you an error. That is the reason what will happen is, avoid this, you must assign default values from the right side. Means you can have B equal to 3. Then if you have another variable C, you can have it as default. And in this case, if you pass only one argument, then A is equal to 5, C is 4, and B is 3. So I hope you have understood why we need to specify default values from the right to left of the argument list in your function header. But the main scenario, that is, such default arguments are not supported by C language. You cannot use default arguments in C language, but in C++, default arguments you can use. So which type of arguments are common to Python and C language? Only your required or positional arguments that we have been seeing all this time. You cannot have keyword arguments. You cannot have your variable length arguments, okay, in Python, other than required positional arguments, default arguments, and keyword arguments. You have your variable length arguments also. These are not allowed in C language. Only required or positional arguments are allowed. So just for your revision, I'll also explain the keyword arguments in Python. Now during function call, A, C, and B are the parameters in your argument list of function header. You have to use those same argument names and assign whatever value you want. Suppose x is 5, y is 6 over here. I'm assigning x to A, to B I'm assigning y, and to C I'm assigning 4. The order in which you specify these arguments means you can use ABC, CAB, BCA, whatever order is not having any importance. It is immaterial. Whichever order you specify the arguments in, it is okay. It will not give you error. So A is equal to X. So whatever A is there in your function header parameter list, the value of A in your function header argument list is X. B will get assigned Y, and C will get assigned 4 in Python. But this is again not supported by C language. And you can have your variable length arguments also in Python. So in C, I repeat, only required or positional arguments are allowed. So if I try to use, now currently I'm not using default arguments, my program is running successfully. If I assign default value to B from right to left, I'm going, will it run? No, it's giving me an error. But in C++, it is allowed. Not in C. Now, what is call by value? Call by value is nothing but whatever we have been doing till now. Means if you have 5 here, that value will get stored in A. If you have 6 here, that value will get stored in B. Now suppose in my main, I have int x equal to 3, y equal to 4. And I want to pass x and y to my function. Then what will happen? The value which is of x, that is 3, will get copied to A. And the value of y, that is 4, will get copied to B. So what I've already told you in my previous video, that the value here and the value here are different. Because x is a variable, A is a variable. X and A are different variables. Means what? They have different memory locations. So whatever value is in x, that cannot be accessed, that cannot be changed by using the variable A. And whatever value of y, that cannot be changed by changing B. Okay, means what? If you change x, it will reflect in X. If you change Y, it will reflect in Y. But if you change A, it will not affect the value of X. If you change the value of B, it will not affect the value of Y. X and A are different, Y and B are different. So this is what X and Y in your main. X and Y are the local variables of main function, and A and B are local variables of mul function. X and Y and A and B are not, they do not depend on each other. Even if you have int A equal to 3 and and B equal to 4, and if I'm passing A comma B here, this A comma B and this A comma B are not the same. So if you change A and B in main function, it will not affect the A and B of mul function. If you change A and B of mul function, it will not affect the A and B of main function. I hope you got this difference. So this is what, there is some security, means your functions can safeguard your variables. So there is some amount of security, not complete security, but some amount. So this is nothing but your function call, which is known as function call by value. There's another thing that is call by reference, but for that you need to know what are pointers in C. So that time we will see call by reference. For now, whatever we have been doing is nothing but call by value. Function call by value. I hope you have understood that here, whatever you pass and here, they will not affect each other if you change any one value. Next, scope and lifetime. So this is a part of revision now. See here, suppose you have your main function, you have A and B in main, and suppose you have func function, you have variable C. Now you might have remembered that in your memory there are 4 parts. One is heap memory, one is stack memory, one is for your data or global or code or static values, and one is your code segment in your memory. There are different segments in which your memory is divided. So stack will hold all the variables or functions, whatever memory should be allocated to them will be allocated or available by stack memory. Then whatever global or static values and whatever instructions in your program, that is code. Now, suppose you have your main function which you have A and B. So whenever it is the turn to execute main, program execution starts from main. So main will be allocated, or it will occupy some memory. Means what? Variables in main will have some memory in this particular segment A and B. Now, suppose you're storing in A, you're storing 3, in B, you're storing 4. So values will get stored in memory. For A, it will be 3, for B, it will be 4. Then when you first declare A and B in main, A is equal to 3, B is equal to 4, you print A and B values, and then this is a function call. What is the definition part? This one. So whenever a function call is encountered, control will jump to what? The function header, and memory will be available for that on stack, and whatever values you declare here, that is C, that will be occupy memory here, and C is equal to 5, that is assigned in the memory as well. And then after all these statements are executed, your control will jump back to function call, and since that is the last statement of your main, so that main will also get terminated. That means what? Soon as the control returns from the definition back to the function call, what will happen? Memory will get deallocated for the function, means this particular segment will no more exist. Okay. Similarly, after the program terminates, the memory for main is also gone. Okay. So I hope you recollected what is meant by local variables. Now, that is the means that was the scope. I repeat. Means what is the scope of this A and B? They have the scope of this main function. Between your curly braces, that is the scope of A and B. Means from your main function, you can access A and B. I hope you remember that you cannot access this A and B from func function. Okay. Means what? The scope of A and B is only restricted to the main function. And what is lifetime means how long your variables exist in your program. As I told, as soon as the statements of func function are executed, control will jump back to function call and memory will be deallocated for func function. So if you are using the variable c in func, after the func function is executed, the memory for c is deallocated, means the lifetime of c is over. Okay. See, now since I'm encountered func function call, control will jump here and then c will be stored in memory. It will be initialized to 5. And then what will happen? Since the statements of func will get executed, so execution of func will get complete. And then what will happen? Memory will be deallocated. Means what? Whatever memory was allocated here, that is gone for func. So whatever variables were stored in memory, that is c in this case, its lifetime is over whenever statements of func execution is over. So that is the lifetime. As soon as the function is executed completely, control will jump back to function call. Lifetime of the variables which are local to func is over. So that is meant by scope and lifetime. Scope is nothing but the region of your program within which you can access your variables. And lifetime is how long they exist in your program. So I've told you how long they exist. They exist only when the function is getting executed. So I hope this point is clear. Now what is implicit and explicit return? This is a very small topic. Means what? In your earlier compilers of C language, or in your early C language or early version of C language, if you didn't specify the return type over here, it used to by default be considered as integer return type. Okay, by default. If you want some other return type like float, then you can mention it. If you want char, you can mention char as your return type. But if you didn't mention it, then by default it was considered to be integer in earlier compilers. So if you specify return type like float, then this type of function definition it is valid. And whenever you call your function like this is known as your function call. And if you are returning any float value, then return statement must be present, and you can return any float value, suppose 3.12. So this is known as explicit return. Why explicit? Explicit means it is not automatic. Implicit means it is automatic. Explicit, since it is not automatic, means since you are, that is the programmer, is specifying return type, so it is explicit. You are doing it, so it is explicit. But if you don't specify return type, it is automatically considered by default as integer, and you're returning suppose some integer value, then it is considered as implicit return. Since you are not specifying return type, compiler is automatically considering it to be an integer return type. It is called implicit return. But nowadays this is not valid. You yourself have to specify the return type explicitly. That is not automatically. You yourself have to specify return type, and so it is called explicit return. Implicit return does not exist nowadays. Now we'll see difference between functions and procedures. See here. Now there are certain gentle differences between function and procedure which you must take care. A function usually has return type and returns a value to the function which calls it. Now remember, for example, suppose I have function 1 here, f1 over here, and I define it, and I have another function, suppose f2, and I define it. Let me just make f2 defining it above f1. Okay, and then you have your main function. Now in your main function, suppose I'm calling f1. Okay, and within, so the statements of f1 will get executed whenever function call of f1 is executed. Statements of f1 will get executed, and if within the statements of f1, one statement is function call to f2, so within f1 you're calling f2 function. So these statements will get executed, and then control will jump back to this statement, and remaining statements of f1 will get executed. So you can call one function within another function. Okay, you can call one function within another function. I hope you have understood this. So, and also remember that these function names that you give in whichever program, these function names, they must be valid identifiers. Means you must apply the identifier rules to the function names also, as well as you have been doing it for your variables also. So I hope you understood how to call one function within another function. So a function can return a value or a type to whichever function is calling it. Usually it is main. And a procedure, it usually does not have return type. Means what? Return type of procedures is usually void, and it does not return any value. Now in functions, you can use data manipulation. But in procedures, usually you should not use data manipulation. Means what? You can use data manipulation, like you can update a particular value, like a plus equal to 2. You can update values, you can compute different values. But usually by standard, the definition of a procedure does not support using data manipulation statements within it. You can use it, it will not give you any error. You can use it, but does not support the definition of a procedure. I hope you have understood it. Then in functions, you cannot manage the explicit transactions. Means if you do any manipulation, it should not be done in functions, but it can be done in procedures. I repeat once again, it means that you can do manipulation, but then it will not be called as a function. It will not give you an error even if you do manipulation in functions, but then it is not called as a function usually. Nowadays, we are saying functional procedures are same and all, but there are certain differences. The description of a function does not support data manipulation within them. So these points are not so important, but I'm just sharing them with you. So you can deal with expressions here, but you cannot deal with expressions in procedures. Now a function cannot call a procedure. Just now I showed you how to call a function within another. Similarly, here what I'm saying, a function cannot call a procedure, but a procedure can call a function within it. And whenever a function is called, that time it gets compiled. Means what? First time you call a function, that time the statements of the function body will get compiled, and if there's no error, you can execute the function. But in procedures, what happens? Only once they are compiled, and then whenever they are called, they are not compiled again and again. Means first time when you call a procedure, it is compiled. Second time if you call, it will not get compiled. But in a function, once you call a function, it is compiled. Second time you call your function, again it is compiled and checked. Third time you call your function, again it is compiled and checked. But that is not the case of procedure. Then it is used to calculate something from input. Means user can allow certain input to the program in functions, and that input can be played with in functions. But in procedures, it is just a set of statements that you're executing. And this thing that is try catch block is used for exception handling in C++. It is not there in C, but functions of C++ can not support, they cannot support try catch block, and try catch block can be supported by procedures. Now what is exception handling? I'll just tell you. Like in our simple calculator program, we have seen our divide by zero exception. Okay, that is a exception is nothing but a runtime error. Means when your program is running, the error can be generated only depending upon what the input is given by the user. If the user enters the numerator as 1 and denominator as 0, then it will give you error. But if user enters numerator 1, denominator 2, then it will not give error. Why? Because denominator should be non-zero and that is satisfied. But if user enters a 0 value for denominator, then it will give error. Means depending on the input given by user at the run time of your program, error can be generated. So exceptions are runtime errors, and they need to be handled in your program so that your program can handle all the cases of execution. So this was the difference between functions and procedures. Not that important, but just for your knowledge. Then what are static functions? See, similar to static variables, what we had discussed in our previous sessions, I'll just show you. See what I've written, initialization happens only once for the static variables. Means if you have static int a, whenever a function is called for the first time, you can assign certain value to it. By default, value that is assigned to static variables is 0, but you explicitly, programmer can assign certain static value to it. So first time when function is called, a is equal to 5. Then next time when function will be called, the initialization part, this whole statement will get ignored, and whatever statements follows this will get executed. So I'll show you a program for this. See a static variables demo program. If I have my main function, I'm printing the message inside main. I'm calling my function for the first time. Leave this commented function call. I'm calling my function for the first time. Then int a equal to 8. And I'm printing the value of a. Then second time when I call my function, then again a is equal to 8 and I'm printing the value. Third time if I call, again a is 8 and I'm printing the value. Let me run this program for you. So here 8 is getting printed 3 times. Why? Because I'm calling my function 3 times. Now suppose I do a is equal to a plus 1. Or I can also write a plus equal to 1, means a is equal to a plus 1. So this time what will happen? First time I'm calling my function. So a is equal to 8, a becomes 9 and I'm printing the value 9. Second time when I call my function, again a is equal to 8 and it will become 9, I'm printing 9. Third time again it will print 9. So when you're running, you can see 999 is the output. Now, if I don't want this a to become 8 again and again whenever I'm calling my function, I have to add the keyword. It is a C and C++ keyword, that is static int a equal to whatever. By default, value of a is equal to what? 0. So if I don't specify at initialization any value for static variables, a is equal to 0 by default. Here if I initialize it to 8, then a will become 9 and I'm printing 9. Second time when I call my function, this whole statement will get ignored. So what will happen? A is currently 9, a will become 10, I'm printing 10. Third time I call my function, a is 10, it becomes 11, I'm printing 11. So when I run my program, 9, 10, 11 is the output. So what will happen? Just a minute. So you have seen the output. Now, if I use static, a is equal to 8. So first time when I call my function, a is equal to 8, a becomes 9, and I'm printing 9. Second time when I call my function, initialization of static variable is ignored, and then it will simply increase from current value. A is 9, it becomes 10, and so on. Okay, for number of times you call your function. So this is the use of static variable. And also note that if you have static int a and if you have int a equal to some other value, it is not allowed. You cannot have a static value and another variable with the same name. Means if your static variable is named a, you cannot have another variable a. If I go to run my program, it gives me error. Okay, if you have static variables and if you have any other local variables, here a is what? Local variable, and this a is static variable. You cannot have same variable name. I hope you have understood this. Similarly, what we can derive the conclusion that the variable is used only once at initialization, and you can use the access the value again and again, but initialization is ignored. Means what? For the function func, there exists a unique a. There exists a unique a value, and you can manipulate that value. But a is unique here for each function call. First time you call your function, a is 8. Second time you call your function, for that same a you are manipulating its value. Third time you call your function, for the same a you are manipulating the value. So what is, we can say that the static values are unique for a function. Static variables are unique to a function. There is only one copy of a available for all the function calls. I hope you have understood. Similarly, how can we relate it to static functions? Whatever function you define, whatever function you define, if you there precede its normal declaration or definition, if you precede the function header with the static keyword here, it becomes a static function. Now, what is the use of this static functions is, this is the syntax for static function header, and rest everything is same definition and function call. The use of this is whenever you develop big C programs, whenever you develop any project in C language, there can be multiple files in that project. So in that file, suppose you have 4 files, you have defined function f1 in file 1. So f1 you want to call in file 2. Okay, filed in file 1, but you want to call f1 in file 2. These files are C files. If you want to call function f1 in file 1 in file 2, and you want the same definition to get executed, then the function in file 1 should be preceded with static keyword. So in all your files, whenever you call f1, the same definition will get executed. Wherever you defined your function, that same definition will get executed each time you call that function in different files. So there is a unique copy or unique definition of that function, which you can call in different files within the same project. So I hope you understood the meaning or the application of static functions. It is relatable to static variables. Then we will see what is the nested functions and inline functions. Just a minute. So nested functions means just like a nested loops. Loop within loop is known as nested loop. Similarly, function within function is nested function. Now, what this means is, suppose you have int main, and then within main I have this message. I'm displaying main at the output, and then I have the function definition of fun function. The function fun is defined within the function main. Till now, what we were doing, we were till now we were defining our function outside the main, right? And we were calling the function within main. But now I'm defining a function in main, that is fun function. Okay. Similarly, within my fun function, I'm defining view function. Okay. See, main function, within main I am defining fun, and within fun I'm defining view function. Okay, just a minute. So now, as I said, within main you're defining fun function, and then within your fun function I'm defining view function. So what I can say, the scope of fun function definition is nothing but it has the scope of main function, and the scope of the definition of view function, it has the scope or the lifetime of the definition of fun function. I hope you have understood what is scope. So within fun I'm defining main, and I'm defining view, sorry, within fun I'm defining view, and I'm calling view outside fun, and I'm calling view, the same view, within main. So view is called inside main and outside fun. Okay, so is this possible? Let us see. So it is giving me an error. It's not allowing me to call view over here. So this is not allowed. You cannot. Why? Because the scope of fun is this much, and within that you are defining view. So you cannot access view directly like this by function call without first accessing fun. Means you have to first call fun function over here, and then within fun you have defined view. So this is the way, but you cannot access your view function directly over here. Okay, I hope you understood this. Then second example is this is what function declaration. This is function declaration, and then within main I have done the function declaration. Then I'm calling the view function and I'm defining it also. So definition of view and calling of view is within main. So here I'm declaring from top to down the statements are executed, top to bottom. So view function is defined here and you can call it here. So this program will give me an error over here, because there is one more thing that you need to take care, that when you have the definition part and the calling part within a same function, that is main, you must precede the function declaration with auto keyword. Whenever you precede the function declaration with auto keyword, such programs will run. Okay, when I run this program, you can see it is executing. In which order? Let me show you. First, what you're doing, you're calling view function. So what is the definition part? View should be printed. So view is getting printed. Then what should get printed? After function, so control will jump from function call to function header. Statements get executed. Control goes back to function call, and then statements which follow function call. That is, main is getting printed. After that, this function definition is ignored, and then you are printing C programs at the output. Okay. Now, one more thing that you can note over here. See here, your view function is returning an integer value. So return type is int, but you're not catching that value, right? The value of this view function is 1. The value of view function call is 1, which you can print, as we have seen in our last video. You can print the value of view function call, which is 1. But even if you don't print it, or even if you don't write int a equal to view, means what? The value 1 you're not storing in a. It is valid. The program will run without giving an error. But suppose you have to use auto keyword, and whenever you call the function, the control jumps here, executes, return 1. So 1 will come here and that will get stored in a. And then what I'm doing, after these statements, I'm printing a equal to %d. So value of a here, this a, and this a are same. Why? Because a is the local variable of main function. You can access it anywhere in the main function. So whenever I print a equal to %d, value of a, that is 1 is returned by function call and stored in a. That value you can print. So when I run my program, see here, similarly view and main, and I'll change the last statement, that is I'm printing value of a is accessible. Next is what? Another example where, see in example 2, whenever you use declaration and definition in the same function, you must use auto keyword, declare it, call it, and then you can define. But if you don't want to give this function declaration, or it is also called as function prototype, you don't want to give this, then what you'll have to do, first you have to define your function and then you have to call your function. That I've done in example 4. First I've defined view function and then I've called view function. In this case, you don't have to use declaration part of function, and you don't have to use auto keyword. Okay, when you have to use auto keyword, only when declaration and definition is within the same function. Okay, that is main. So if I run such a program, it is running the same way. Why? Because I have first defined and then I have called. If you don't define first, you have to use declaration and auto keyword. I hope you understood nested functions. Next topic is inline functions. Now, what is the difference between your normal function and inline function? So the theory part I will tell you. So inline function is nothing but, see, whenever you call your function normally, like add and pass parameters, and you define it, what will happen, as I've told you all this time, control will jump from here to here, execute the statements of the function and jump back to the function call, and then following statements will get executed. But this involves a lot of work that needs to be done by the compiler. This involves a lot of work that needs to be done by compiler, because in big programs you won't have single function calls, right? You'll have many function calls, and you may call one function within another function. If any value is returned by a function, that also needs to be taken care. So what will happen for big functions, such definition is okay. Means what? If you have 100 statements over here, if you have 100 statements, or suppose 50 statements in your function, then such way of calling is okay. But see here, I have only one statement, that is printf in add function. So whenever I execute the program this way, control will jump from here to here, execute, suppose I want to return any value, and come back here. So to avoid all this, what I can do, I have to make this function as an inline function. How I can do it? By preceding the normal function header by the inline keyword. So what will happen at compile time, means when your compiler is compiling your program, that time, instead of this function call, whatever you written in the definition part, that will come here. Means what? I'm not jumping from, the control is not going from calling to definition. Control will not jump from function call to function definition, but instead of that, whatever definition part is there, that will get accessed, and it will be replaced with the function call. Means the whatever statements are in function call, in function definition, whatever statements are in function definition, that will come in place of the function call. Function call will not be executed, but the statements of the function will get placed instead of function call. I repeat, wherever you have function call, that will be replaced with the statements of that function. Okay, at compile time. So here, instead of the function call, what will happen, what will the compiler consider? Whatever statements are there in the function, that particular function, and it will come here. At compile time, this replacement will happen. Okay, not at runtime. So this is the way you can reduce the workload that is carried out by compiler. And another thing, suppose I have certain return value by add function, and I want to add it with the return value of sub function, suppose. So in particular order, these functions will be called, which depends upon the compiler. Either add will be called first, or sub, or sub will be called first, or add. And those values I'm adding and storing in another variable x, suppose. So what will happen? Control will jump here to x. Since assignment operator has least precedence, whatever is to the other operations to the right will get executed. So add function will be called, control will jump to the definition part, executed, control will come back here. Then sub function will be called, control will jump to definition, execute everything, control will come back here. Then whatever returned values will get added. So all this is too much, right? So instead of that, whatever values are here, that will get replaced by this. So no need of jumping from here to there, it will save your time. That is what you must do in big programs to save time. And it also saves the memory resources that your system holds. Okay, so we have covered all the topics in the unit functions except a few predefined functions we'll see later through programs. And the different programs of functions that we can execute we'll see in our next session. I hope you have understood all these concepts. So you can see this video whenever you are free, any time of the day, and whenever you take a break from your studies, you can understand these concepts. And if you have any doubt, on 12th May when we meet live from 5:30 to 6:30, you can clarify your doubts. And if any other doubt, and if it's urgent, you can message me on WhatsApp. I hope you understood all these concepts. Thank you for watching this video. Keep learning.